this IP address, this is the one which you set it up in here, okay? So how is the practice going on? Are you guys making a document on the side that I told you to and start putting that into the document that what you're learning so that it will help with the resume? So do that on the side, okay? Uh, so let's see what we're gonna do today. Okay, so this is the easy one and important one. So what we're gonna do is we're gonna enable what HTTPD is. Actually, this is the name is wrong here. Actually, this is um, give me 1 second here. Okay, so the one we have, the one demonstration we have here is for Red Hat 7. So I'm gonna start Red Hat 7 on here, and you do the same too. I'll put in the link in here so that you guys could go ahead and start downloading Red Hat 7. Don't download it until I put a link in here, okay? Not there in the notes. This is 6.9 we've been using, so we're gonna move on towards Red Hat 7 now, okay? All right, so
Are there any differences with Red Hat 7?
uh actually what is going on right now is Red Hat 7 is out for like 5 6, I mean at least 5 years, but not everybody is using it. Maybe only like 10% of the companies out there are using it. And there are some essential core differences. I will actually go over that, okay?
Okay.
So what I'm gonna do is actually, I'm not gonna show this one here. I'm gonna show you how to set this up. Same thing in Red Hat 6, the one we are using. Then I will go over this later on because I want to keep Red Hat 6 and 7 separate. Let me open my notes here. Linux notes. It's opening up. Oh, oh, I was on mute. So very first thing we're gonna do is uh, start installing, what I'm going to show you is how to configure a web server. Like, you could go to a websites and then you could see their websites and all the applications are running behind it. This is how it's done. So what you should do is you log in as root and then you type yum install httpd. Most of the time it's installed, but I would say 50% of the time it's already installed, but you have to check to see if it's already installed or not. So what you do is type which httpd, and to me it is saying that the httpd is installed, but I'm going to run it anyway. Yum install httpd -y. When you type -y, what's happening is it will automatically it will not wait for your confirmation. It will start downloading it. Okay, so very first command is yum install httpd, and let me hit enter. Okay, it says the package is already installed, so nothing to install here. Let me go ahead and put that in here. This is what it installs. Okay, this is the package name. What a package name means, this is the software name it downloads. Okay, so the second command is you type service httpd status. Okay, we see that the status is stopped. So what we're gonna do is we're gonna start it. So then we have to give a command start. Okay, and you see, go ahead and check the status again, and it says is running. So you do this, and then what you do next is find the IP address for this host. You type ifconfig. Okay, oh man, this is bound 0. We'll see if this is gonna work. So what you do is you take the IP address and you put it in here, and we'll wait and see if it's gonna work. So it's not working. So what we have to do is we have to disable the IP tables. Oh, can you hear me? Hello?
Yes,
Microphone fell
yes,
off.
we can.
Yes,
Okay,
yes.
okay, sorry.
Yes.
Okay, now you see that we try to use this IP address and try to go onto the website. It's not working. So what you have to do is um, you have to do chk config and then grep IP tables. Okay, so we are in run level 3 and it says it's on. Okay, so run level 3 is on. So what we're gonna do is we're gonna turn it off. Chk config IP tables off. Let's go ahead and run it again. So now it's off. Let's see if it's gonna work. So let's go ahead and do another command here. Service IP tables status. Okay, so looks like the IP table is on actually. So when what we did here is we ran this command to turn it off, right? It will be off next time the computer reboots. Okay, let's go ahead and refresh here. There you go. We have all of a sudden we did this configuration here. The website loads here. Okay, so I'll show you how this website is working. Service. Actually, I want this numbered. There you go. That's number 2. And number 3 is this. Number 2. Number 3. Delete all this. Delete all this. Okay. So let's see. What was the number 4? Number 4 was, okay, we could go from here. Number 4 was we started the service again. We did the status and then we have to do the status one more time to make sure it's working. Then number 5 would be check ifconfig. And then put this IP address into the browser. Okay, for you, the IP address is going to be different, right? You have to type ifconfig and check it, okay? And then the number 6 it would be you have to run this command to see if the IP table is running. So when you see this IP table is on, you have to run this command to turn it off. So number 8 would be to turn off the IP tables next time it starts. Then again, you go run this command service IP table status and see if the IP table is still on. And then when this IP table is still on, you run this command service IP table stops. What is IP table? I told you guys last time. Can anybody recall? IP table is your firewall. It says here that IP table's firewall is not running when you run this. So what does firewall does? Firewall does like something from outside coming in and something which is secure. It stops it from being displayed. Okay, so let's go ahead and go in here and make some changes here. So this page is being displayed from this this page. Okay, what you could do is you could open this page and try to edit it here. Let me see. Okay, so this page this page doesn't have this folder doesn't have anything in here. So let's go ahead and go cat this out and see what this one has. When I cat something out, what does it mean? What am I doing? When I cat something out, that means I'm reading it. I'm reading I'm reading I'm reading the file. I'm not going into VI editor. VI editor will take you into the edit mode, but if you just do the cat and the file name, what it does is it will help you just quickly read it. So this one is a very small file, so it doesn't make sense to use VI editor and go and take a look. But in here, you could do whatever you want and then take a look here. So I'm in this folder here. I'm in this folder here, var www/html. Okay, what is it gonna do? This is where you put your index file, and then this is how the website will start showing up here. So let's see here. What am I gonna do? Okay, did you see what I just did here? What I did here is whatever you have in here, if you name something as index.html, it will take it as a default file. Okay, it will take that as a default file and it will start reading that here. The moment I rename it as something else, let me see if it's going to work. If I name it, I'm going to name it index 1. Then let me refresh this here. Okay, so what I'm trying to make a point in here is it reads file name exactly the way it's typed here, index.html. So we renamed the file here. Index.html is not there here. We have index1.html. Okay, this is where you create your web page and put all your documents in here and everything. This is where this is the starting point of a website. Okay, so what have we done so far? We just set up a website. So when you are working with the application team, this is what they're going to be doing in the background, setting up a website. So let me go ahead and try to edit this and put some meaningful text in it and see if it's going to work. So let me go ahead and delete this. And then I'm going to put in some HTML code in here and see if it's going to work. So let me go to here. What I'm going to do here is view source page. And then I'm going to select all. And then I'm going to try to copy it in here. Hmm. What happens? It freeze? You can't go in there. Okay, I'm gonna try to put like a smaller code in here. Okay. Okay, it says loading. It doesn't like that. Course notes. Give me 1 second. So let me go in here and let me delete all this. And then let me put some code in here. Don't worry about this. All this coding, all this thing is not your job, but I'm just showing this for the demonstration purpose. Okay. So I have a bunch of code in here. Let's see if it's going to work. Oops. Okay, I removed it. But here's the thing here. What I'm trying to show you is whatever this folder has, and this folder is usually empty, but the moment you start putting in the file, the name starts with index.html, the browser will start reading this file as a default file. So what your job is as an admin is just to do this here, just to from number 1 to 12, just to make sure all these things are working here. And then the coding and everything is done by other people. Yeah, they're called developers. So I'm going to just copy this and put it in here. Okay, I'm going to go ahead and upload this document later on. Okay. So since we have a full, very good attendance today, so I'm going to try to cover network today. It's a long overdue. So let's go ahead and take a look here. Okay. All right. So on network, I'm not going to go way too much in detail, but I'm going to just briefly touch on all these things here. So when we are dealing with the network, for us to be able to start communicating with other computers, we need to have a NIC card. Okay. NIC card is, okay, this is the NIC card that's inside the computer. Computer in the sense server. Okay. So you need to have that. And then you need to have a media. Media would be, the cables and all those considered as a media. And then topology. Topology is what kind of topology the system is using. Okay, we're going to cover this here later. Protocol. Protocol is something that was designed by the IT experts. And then the IP address. We all know what an IP address is, right? When you type ifconfig, you will see the IP address. So this is the IP address that receives the signal from the other computer. So when the computers are talking to each other, they talk using the number here. So the IP address is like the mailing address for your home. Okay, so the NIC card has a unique hardware number. So remember I told you one time that there is a unique hardware number. So the NIC card has that. So every NIC card has a unique hardware number. So it will be all different. So this will be different from this one here. Don't look at this one here right now. It's a bad example because it's using bond 0. When we add another NIC card in here, it will show you a different MAC address. In other words, it's also called a hardware address. Okay. And then to look at the IP address in Red Hat 6, you just type ifconfig, and in Red Hat 7, you type IP space ADDR. Okay, you type IP space ADDR, it may or may not work. So the information it's giving here is not enough here, but when you use a real Red Hat 7, it will give a lot more information here. Okay, so the cables are just the cables and RJ45 jack, the cat and all that. You know all these things, right? RJ45. So RJ45 is just your cable in your home, network cable. So RJ45 is a plug, and then the network cable is, this thing is called Ethernet cable, okay? And then the plug to the end is called RJ45. RJ45. And the topology is, there are like about 4 categories of topology, how the computer communicates. One is called ring. So there are like several computers. These are old days. The computer used to, if the computer has to communicate with the computer next to it, if it's a ring topology, it goes from one computer to another computer and then goes all the way in the ring, and then it communicates to this computer that way. So if you want to communicate this computer, so it just goes from this to this to this. So if one computer goes down, then the ring is broken. So all these computers cannot talk to each other. Okay, this is old days here. Similarly, after a time, a uh, bus topology developed. So what it has is it's like a bus here, straight bus, and the data flows from here on this cable here. And then if you want to communicate with this host here, for example, what it does is it will put the information on this cable and then this host will get it. Okay, similarly, if it want to communicate with this host, all it does is put it on this cable and then whoever is intended to, it will give the signal will go there. Then as the time passed around, the star topology came in. That's where the switch was invented. So we have a switch in here, and then we have all these computers. If you want to communicate from this computer to this computer, you send the signal from here to switch, and wherever the switch is, it need to send this to the computer. It will calculate it for you and then send it here. And then we have tree. So as you could see, it's obvious that this thing involves into a tree. So if you have one switch here and from there you could have like another switch here and then have more computers from there and then we'll have more computers. So if you want to communicate from here to here, all you have to do is send it here, it goes here, then it goes here and then bounce around and comes, finally it goes to this place here. So unlike in old days, all these three are like more reliable. So first one, two, three are gone or barely being used, but most of the networks are tree topologies. So if you send a message, it goes somehow, it goes through all the other systems and then goes to the endpoint. Okay. So there is something called OSI layer, Open Standard Interconnection Model. So what it does is if you're really deep into networking, you would end up studying a lot more about this OS model. OS, I'm sorry, OSI model has like about 7 layers. So how do you remember this? You just type remembers PD, NT, SPA. So what is physical? These are it has 7 layers here. So data, when you have a data on your computer, it has to have somewhere on a physical layer. Okay, physical layer is hardware, and then data layer is this is where the magnetic tapes and all those things that come into place. This is where the data sits, and then from there it goes into the network layer. Now it's coming out of your computer, and then it goes into the transport layer. Transport layer is where this is all the Wi-Fi switches and everything is layer. And then before it goes to the just before it goes into the intended host or intended computer, it will open a session layer. There is a session layer, and then also there is a presentation layer. It presents it, then whatever the application is. For example, if we have a data that we are receiving a data when we type RJ45. It went through all this thing here. Wherever this picture is sitting, it came from physical layer to data layer to network layer, then it went through transport layer, then from here it's on our computer. So our computer is on a session layer. It calculates it and then it makes use this layer as a presentation layer to make it available. And then the application is this browser here. Chrome is an application. This is what it's reading, what the presentation has to show to you. Okay, so remember, this is just like I'm done in like 2 minutes here, but this is like a whole deep uh, a deep IT space in itself. People who are working on a network, they have to go deeper and deeper into this. You would spend your entire life in here, but you still be learning what's in here. So don't just look at this and say, okay, this is it, because I'm not showing all this here because we're not concerned about this. If we are having some network issue, all you have to do is you type ifconfig and see if this is being configured or not. So If you do like, if you're not able to connect to the outside world, if you do ping google.com, and if you are not getting any response, then you would further troubleshoot the issue. So I think last time we couldn't ping it, so today we're gonna try to troubleshoot this and try to resolve this issue. Okay. So in the transport layer, we are concerned about. We're not gonna go much deep into any of these, but we're gonna concern about transport layer. We're gonna look a little bit deeper in, not a little bit as much, but only worry about these two protocols, which lies under transport layer. So there are a protocol called UDP. What UDP is, like Universal Datagram Protocol. Where is this coming from? This is something you remember it from the old days of Telegram. This is where the UDP used to be. And then there is something else that involved TCP, and it's called Transport Control Protocol. If you might have heard about TCP/IP, right? This is what it is. This is what it started off from. Transport Control Protocol. So in the Transport Control Protocol, what we're going to do is we're going to look at the a little bit deeper in here. Okay. So what we're going to look at in, so we're going to work within a transport layer. There are sub layers in here. It's called a data layer, network layer, transport layer, application layer. I'm sorry, these are some of the layers that we are concerned about. These protocols, use the data layer from the OSI model, and then the network layer, the transport layer, and application layer. Okay, these two layers we are not concerned about it. This layer we're not concerned about it when we are using TCP, transport control protocol. What this protocol does is it uses the data layer, network layer, transport layer, and application layer. So how is this connection is established? So we have one host here, host, a server, a computer, doesn't matter what you call it. If you guys are going to be a Linux admin, it's better you guys call this as host. Day in and day out, you call this as host, and this is host A and host B. So what's going to happen here is there is a there is going to be a communication between the two computers here. So what it will do is it will make a connection. Before it makes a connection here, it's called a three-way handshake. Very first thing it's going to do is three-way handshake. What it's going to do is going to send a host A is going to send a signal to host B. Okay, it sends one-way signal and it's called sync. Okay, it's called sync. So what B does is B receives the signal and then it will respond with sync, and it will also at the same time send a message to A that I received your message sync, and then I'm sending it acknowledgement back. So it takes it, receives it, and attach acknowledge back, and then send it to A. Okay. So when A gets it, then A sends a message that it got this message and says acknowledge. So this type of communication within TCP is called sync-ACK. Sync-ACK sync. So this is what the term is. Sync, it sends one way, sync. Then sync-ACK is the B is responding. Then A is responding again. So A is responding sync, and then acknowledge. First time it's acknowledging, sending the sync signal. Then B is sending sync and acknowledge simultaneously. Then A is sending acknowledge signal on the fourth attempt. So what you have to remember here is you just remember how this is called a three-way handshake. So one way, two-way, three-way. So once this handshake happens, that means a connection is established. what happens? The connection establish. Sync act, sync act. Then to close the connection, it does the same thing. Sync act, sync act. Okay. So do you have any questions? I think you will have at least one question here. Anybody? Bashar, Yaqub, Abdul Malik. Did you get it? Okay, I'll
I
take it
think
as
I
yes.
understand it.
Huh?
Sorry, yes, I get it.
Okay. It's simple as the diagram looks, and then you could go here and review it again. So now the bottom one is these four things I put down here. These are just the abbreviations and then what it means here. Okay, it's being used in here and it's being used here. So the top one we looked at it. Sorry, I misspoke. The top one we looked at it's establishing a connection, and the bottom one is closing a connection. So what happens is server A here, when it's about to close the connection, it will send fin. Fin is finish packet. So it will send, after sending a data, it will send a finish packet and says there's no data. It will send that signal to here. It says no data. And in the server over here, it says, it tells the client, host A and host B here, right? So host A sends fin. It will say, okay, I'm finished. So the server B says, okay, I got your finish, and then I'm finished too. So it says acknowledgement, and it says finish. Last communication, it says, okay, I got it, and then it says, yeah, I confirm that you are done too. So it confirms that the connection is closed now. So this type of connection closing, this is a connection establishing, and this is a connection closing. All these things are happening in a milliseconds, fraction of a second. You could barely see all this happening. It's already been done. By the time you say done, it's already done. Okay, this is what's happening here, and this is what is happening here continuously. If you're downloading something, it's going there, downloading, bringing back, and FinAC and ACK and all these things going on simultaneously. So each packet, when it goes through, after each packet, this is called a transaction. These are the transaction that is happening here. What is a packet? It's like small piece of information, small piece of data information. So if you think you're downloading a picture, that picture may have like 1 megabyte, right? 1 megabyte is thousands of bits of data. Okay, so what's happen is when you download a picture, all this sync and syncAC is happening about 1,000 times. It's just like the rotation in your car. Your car pistons goes like, just to go for you from your home to a grocery store like a mile away. You don't think of it. You just say, oh, I just went 1 mile. 1 mile is one megabyte of picture size. But the piston inside your car, they're going up and down thousands of times probably. Probably it went up and down thousands of times. You get the idea. Okay, so this is how these things happen here. And use, okay, yeah, don't worry about this. I'll cover this about the TCP dump utility. And then there are two things happen into the involved for network communication. Okay, one is IP address and the second one is network port. IP address, we already looked at this IP address, right? IP address is the home address. Port means like a shipping port, like where is the ship is going to dock, right? So in computers, when you look at this IP, the computer as your home, and IP address is the address of the home, and then you have like several windows, several doors, right? If you have a UPS coming in, you could tell them to go into the back door or the front door, So a big business has so many delivery doors, so they start to put numbers on it. So this is what exactly this is. So once the computer has it, the computer has ports, that means doors. It has the I think it has 65,000. Each operating system has 65,000 ports on it. Okay, so a computer would have about 65,535 ports. 65,535 ports are nothing but they are what they are? Doors. So the one we are using to communicate, connect to, for example, if you're connecting to port 22, that means you're doing a SSH. If you're using a FTP, then you're using port 21. If you're using FTP, then you're using port 8. Like this, by default, all these ports are turned off. But when you install some application, like when you install SSH, it will open that door up. And then that's where this is reserved for. This is reserved for SSH to communicate on port 22. So if you have noticed here, have you ever wondered what this port number 22 is? Port number 22 is, we set this up by default. Port number SSH is set to port 22. We could definitely change that. And then what we could do is we could run a simple command, ps-ef, and then we grep. What does grep means? Grep is nothing but grabbing it. Okay, and then no, not this one. You type netstat, and then you grep for 22. Okay, so what this is doing is, okay, hmm, hold on. Okay, I couldn't find it, but right now these are all these connections here that are being used right now. These are all these ports. There are a lot of processes which are running in the background here that you may not be aware of. But the good thing is, by default, the ones which are not supposed to be open, they are not open, they're closed. You physically have to open it. Okay, here, this is the command I was looking for. You copy this command and you paste it in here, and then you go up and delete. Okay, here. So what's happening here is, this is port 22. That means door number 22. And yeah, this is where the door number is. Door number is right now, it's using this IP address. So this door number, what is it's using? It's using IP address, and it's using to establish a TCP connection. And that TCP connection is used by SSH. Like, you know how you can connect from one computer to another computer? And this is also being used to establish connection to the outside world. This is very important, port 22. It will be in your interview. What is the connection? What is the SSH port? It's port 22. Okay. So over here, I put a note in here that hackers would exploit port number to get into the system. So it doesn't have to be port 22. It could be any port which is open unintentionally. It will be open door for hackers. They would try to go in and hack, and then that way, that's how they try to gain access into your system and then try to steal your data. Okay, let's see here, system hardening. So all these things are most of these things are done by a security group. So when you end up on being in a job position, you don't have to worry about all this too much, but you do have to worry about if you're not able to connect to uh, if you're not able to connect to another computer, then what you would do is you would run this command here. There is a command I'll show you a little later that you would run it to see if that port is open. Okay. So over here is showing here that if you want to change the port number, you could do it in this file. Okay, so okay, right here, this port is using port 22. So I'm going to go ahead and make it 222. But before that, you just go into Google and then you go here, port 22. What is port 222? What is port 222 used for? There you go. Port 22 uses TCP connection. So right now it's turned off. So what I'm going to do is I'm going to go ahead and save this as port 222 and see if it's going to work. So right now I'm going to restart the network and see what will happen. Okay, so I have disconnected, the system disconnected at me. So if I go in here, if I go new session, and then which one was that? Okay, so if you see previously I was using IP address 133, right? So let me see, let me try to open it. Oh, it opened up. So let me see if it's still. Okay, what I'm going to do is I'm going to try to connect on port 222. So this IP address for this one is 133, right? It's using 133 and it's using port 22. So I'm going to try to do connect to port 222. Okay, connection refused. Okay, so we did a mistake here. So we're gonna have to go in here, and then we uncomment this. Okay, escape out of this, and then let's try it again. Okay, let's restart the service. Okay, it's now working. So let me see, change. Oh, this is Ubuntu. Okay, let's go ahead and give it another 2 in here. Okay. All right, let's see if it's gonna work now. In here, I'm gonna put 4 twos, and then I'm gonna try to connect again. 2, 2. There you go. Now we remember we weren't able to do it, but you should be able to connect almost to any port here. But here's a demonstration here. Port number 222 was off, turned off. We just turned it on, and then we are using that port to use SSH. So you could log in as root, password, and then you could run that command that we found in there. You could run this command here again. You could run this command in here. Again, it didn't find it. Okay, and then you could type 2222. See? What happened in here is officially it is running on 222. Let's see if I could make a duplicate connection again. See? If once I exit out of here, I won't be able to connect using port 22. So if I come in here and then go in here, and then the original was this one. Remember 133 was on 22. Now it's 22. So let me see if I could connect to 22. Okay, see, I'm not able to connect to 22 anymore. All right, let me try to see if I could no. So what I'm going to do is I'm going to change it back again to its original so that I don't mess up too much. So I have to go in here. Okay, and then I could change it back the way it was. And then you run this command here, the one we found. Where is it at? Okay, let me see if I could make a duplicate connection. See, I'm not able to connect there anymore. Okay, so this was the old one which was using port 22. Let me see if I could connect. There you go. Let me close this out and do it again. So I'm going back in here and then I'm loading Red Hat and then I'm using port 22 because we changed it back to 22 and it is working for us. Okay, so these are the little things that you will be tasked. Don't worry about this too much here. When you go into this job, they're not gonna be expecting you to know all this here. What they're gonna be doing, asking you is if you are able to do this basic commands and VI editor, and everything else is documented how you do it, because all the different corporations they have their own instructions how you would be doing it. Okay, so if you get hired and then you're freaking out that you don't know much, don't, because you already know a lot, because they couldn't find anybody who is able to like type any command here like pwd ls-l. They just can't find people who could do this basic things. So you are in a safe place. Okay, don't worry about it. So the next protocol I'm going to briefly touch on this is called a udp. Oh, by the way, uh okay, so let's see what udp is. A udp is a connectionless protocol, and it's very fast. What it does is, over here we are using a TCP connection, right? And this protocol is working so hard. It's making sure the data is sent, data is received, data is sent, and then even for closing, it's acknowledging, sending, acknowledging. So it's working hard. You could see like how much transaction is going on, right? To make a connection, it is going one, two, three. It's going almost four times back and forth. I mean three times. One, two, three. So here, and then to close the connection is going working so hard four times. One, two, three, four. So now what UDP is, we have a client A here and client B here. It doesn't care. UDP doesn't care. It just throws out the information up in the air, and it doesn't care if the server gets the if the server gets the message or not. That's why it's called broadcast. So where is this coming from? Where is this term coming from? Broadcast means from radio. So radio, when the news is coming on the radio, they don't care if the other radio receives or not. Okay, they just broadcast it. It's up to the radio you have in your hand to receive it. So what is the poor radio is going to do? Wait for another signal for it to come. So what happens for this server, if it doesn't receive the signal, it just wait for a new one to come in, and hopefully it will gather the information. So this is really important here. Memorize this. So we just went over this here, TCP and UDP. So TCP is the program that uses TCP protocol, and UDP is user datagram protocol. So you will need to know the differences. So what is TCP does? It's a connection oriented protocol, and UDP is connectionless protocol. Okay, TCP is reliable. Why is it reliable? Because it's working so hard. It's making sure that data packets are going back and forth, and it's receiving the confirmation before it closes the connection. So UDP is not reliable. It just throws out the data at the other users or the other computers or the other receivers, and it just doesn't care. So TCP acknowledgement will be sent and received. So when you're using TCP, you receive the acknowledgement. When you're using UDP, there is no acknowledgement. For that, even though this is considered pretty fast compared to UDP, it's slow because it's only one-way connection, right? There is no two-way connection. So obviously it's going to be a little bit slow. TCP is going to be slow. And the protocol is called the number the number which it operates is called number 6, and then the protocol number which UDP is operating is on 17. Remember this, number 6 is for TCP and number 17 is for UDP. What kind of services are using TCP? HTTP, FTP, SMTP, and TCP. So HTTP is what? This one, when we open up a web browser, it's using HTTP, okay? And then DNS. What is UDP using? It's using DNS, DHCP, and UDP. So DNS will go deeper into that. DHCP, we may or may not. I'm not sure if we are gonna. Okay, and then it uses the UDP. Okay, anybody has any questions? Okay, so I'm gonna cover a little bit here about IP address. So when you really look at this IP address here, uh, so this address we are looking here is actually not a decimal number. Okay, decimal is like 192, 168, 1.133. You're used to this number here, but in essence, it's not a decimal number. What it's using is it's uh, it's using okay, let me Google it. Okay, so what this is the to your eyes it looks like a decimal number, but this is not a decimal number. What it's using is in bits. Let's see here. This looks good. Okay, here. So what it's using this in a bits here. So to my diagram, what is first bit is its first bit is 2 to the power of 0 multiplied by 1. So what happens is, what is 2 to the power of 0 is 2 times, there is nothing being multiplied, it's 0. 0 times 1 and it's giving the answer is 1. And what's happening here is 2 to the power of 1 multiplied by 1 is equal to 2. Okay, and then what's happening is 2 times 2 multiplied by 1 and it's giving you 4. Can you guys see that? Is it better now?
Yeah, that's better.
So you have went through this in your grade school, so I don't have to repeat this. So if you go like 2 to the power of 4, what it is about 16. Okay, 2 times 2 times 2, 2 times 2 multiplying each other by 4 times. Okay, 2 times 2 times 2 times 2 times 4. This is what's happening here. So what's happening here is, so the very first one, it says 2 times 0 times 1 is coming up to 1. Okay, that's how it is. And then the second one is 2 times 1 times 1 is coming out to 2. Okay, and the third one is 2 times 2 times 1 is coming out to 4. Okay, 2 times 2 4, 4 times 1 is 4, right? Now you get the idea here. 2 to the power of 3. It's not like 2 times 3 equals 6. No, it's not that. 2 times 2 times 2. Okay, so it will be 8. 2 times 2 is 4. 4 times 2 is 8. This is what's happening here. 2 times 2 times 2 times 2 times 2 equals, what's happening here? 8, right? 8 times 2 is 16. Okay, and then same thing is happening 5 times. 2 times 2 times 2 times 2 times 2 equals, what's happening? 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2 32. Okay, and then 5. Now we are on to 6. 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2 4, 4 times 2 6, 6 times no 8, 8 times 2 16, 16 times 2 32, then 64. Okay, so we are on 220 28 bit here. So 2 times 2 times 2 times 2 times 2 times 2 times 2 equal, so up here is 64, now times 2 is 128. This is where all this digit stops. So this is how it's calculated here. So let's go ahead and do a little math here and figure it out. So IP address of 192.168.10.100 is this. In binary, it's coming out to 1110010001000, all this. So this is what the computer is looking at. To the computer, to your eyes, this is 192.168.10.100. To the computer, this is what it's looking at. This is what is called a binary. Okay, let's go ahead and do the math here. So let me show you how this works. So we have our IP address 192.168.1.33, right? So let me copy this formula. Oh man, hold on. Okay, so what we have here is, so we're going to convert, we're going to convert we're going to convert our beautiful IP address 192.168.1.33 into, we're going to convert it into binary. So how are you going to do that? Okay, so what you have to do is you have to look at the very first one. So very first one is a 192. So what you have to do is type 192 and then out of 192 subtract 128. Okay, so if you subtract 192, then remove 128, what is left is 64. Okay, so once you have a 64, that means we use this bit. So we're going to put 1 in here. Okay, and then 64 is left here. So the 64 is from here is carrying over here. 64, and then what this field is offering 64. So you have to remove 64 out of it, and then what is left is 0. So since we use this field, 64 was able to detach from what we have. So we're going to put letter 1 here. And then what is carrying over? 0. So we're not going to remove anything out of 32. 0 minus 32. We're not going to do that. So we're not using this field. So this will be 0. And now we are not using anything else. So 0, 0, 0, 0, 0. So 192 equals 11000000. 168 now. Okay, we put a 168 in here. 168 minus 128. So yes, we are able to subtract 128 out of 68. Okay, so how much is left? 40 is left. So we're gonna put 1 in here. That means we use this field. And then, are you able to see? Let me just make it real bigger. Okay. move this up a little bit. Okay, now, so 40 is left. So I'm going to type 40 here, and 40 minus 64 is not a positive number coming out. So we're not going to use this. So we're going to leave 0 here. Okay, so what we're going to do is we're going to skip this. Now we're going to carry over 40 again over here. 40 minus 32 makes sense, right? What is left? 8 is left. Since we use this field, we're going to put 1 in here, okay? We didn't use this field, we put 0 in here. So how much is left? So 8 is left. So we're going to just remove 16 out of 8. So it's not going to give us any positive number. So we're going to skip this. Since we are skipping this, we're going to put 0 in here, okay? Now what is left still? 8 is left. 8 minus 8. Yes, this is working, so it's 0. So we use this field, we put 1 in here, okay? And then what is left is 0 here, right? Since the rest of it is 0, so it's going to be automatically 0. 0, 0. So to computer, what 168 means is 1, 0, 1, 0, 1, 0, 0, 0. So to computer 192 to our eyes, this is what it means. To computer in binary, this is what it means, okay? All right, now we're down to 1. Okay, so what does 1 means? What does 1 means to the computer? Okay, so obviously all this is not, so obviously all this is not going to work, right? So from 1, you're not going to remove 192. I'm sorry, 128. So we're going to skip this. So 0 goes here. So you get the idea, right? So we are the ones we are skipping, you put a 0 here, 0 here, 0 here, okay, 0 here, 0 here, 0 here, and then 1 minus 1, that something is working, so we put 1 here. So to computer, 1 means 1, 2, 3, 4, 5, 6, 7, 8. So 7 zeros. Okay, this is what 1 means. It's not like 1 means 1. It has to has all these zeros in front of it for it to be able to calculate that as 1. Okay, and then what is the last one? 33. So let's calculate 33. What does 33 means to the computer? So we're gonna try to remove 33 minus 128. It doesn't fit well, so we're gonna say skip. So we put down 0. 33 minus 64 doesn't fit well, so type skip. 0. Okay, 33 minus 32. Aha, we got something here. So 1 is left. So we use this block. So we put on 1. So 1 minus 1 is left, right? So 1 minus 16, it's not going to be a good result. So we could skip. So 16 is going to be 0. So 1 minus 8, it's not a good result. Skip. 0. All right. And then 1 minus 4. 1 minus 4 equals not a good result, so put 0. So 1 is still carrying over. 1 minus 2 is not a good result. We skip that. 0 and 1 is there. 1 minus 1 is a good result. That means 0 is coming out. So we did use that block. So 1. So whichever block is being used, you use that block as 1. So to computer, 33 means 0, 0, 1, 0, 0, 0, 0, 1. Okay, this is what our IP address for this box 192.168.1.33 is actually this, 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 this. Okay, any questions? Yeah, any questions? Let me know. If not, we could move up. Are you guys still with me? Can you hear me?
Yes, I can hear you.
Okay.
Yes.
Good. So we have 15 more minutes. Okay, I'm gonna take a little quick test here. So Bashar, Yaqub, everybody log into that system here. Go in there, go into assessment, and then launch that system here. Go in there, and then right now from your computer, go there, and then I'll ask you to do some commands, and I want to see how you guys are doing. And then I'll connect myself from here too. Are you connecting?
Yes, I'm already connected.
Okay, so